Let's say you are streaming music on Spotify and you don't like the song that's going to be played next, so you want to pick your own song, but you don't want to stop the current song that's playing. Um, so I often do this, and what I do is I find the song I want to play next and I just in queue it. So it's added to my queue and it'll be played next after the current song finishes. So the idea of queues is pretty important in computer science, and stacks and queues, these are kind of these abstract data types that go hand in hand, and there are some very clever things you can do with things like stacks and queues, and we can talk about priority queues as well. What do queues actually look like, and what kind of operations do they support? So these are abstract data types. So we care about its interface. We won't really care about the implementation for now. But turns out the implementation is also very important depending on whether you're implementing it using linked lists or reverse sorted linked lists or unsorted linked lists. You have different optimizations you can opt for. But turns out there's a particular data structure called heaps that we'll talk about in the next video. But for now, let's actually look at how these queues are behaving. So how we interact with these queues. So I mentioned before that we have just a plain old regular queue, and we have something that's a little more special. It's called a priority queue. Priority queue. And both of these support some pretty good operations that are useful in things like streaming music or scheduling processes and things like this. So let's talk about them. So a queue might have um, an operation that allows you to add add something to the queue. So the queue stores some data and you want to add data to the queue. And how do you do that? Well, you have to in queue it, right? So you in queue to the queue this piece of data you want to add. So okay, that's in queuing it. What about if you want to remove the piece of data you from the front of the queue? Because remember how queues act is you they behave. I guess I should mention they behave in this fashion: first in, first out. Whatever you put first into the queue is the first thing that moves out when you dequeue something. So if you dequeue something, it'll go to the front and find out what was the earliest thing you added in the queue, and it'll remove that. So it'll pop from the queue the front, whatever's at the front, and then it'll return that. That's dequeue. Now, say you don't want to pop it from the front, you just want to know what's there. You just want to kind of peek at that front element. Well, we have a method called peek, and you can peek at what's at the front of this queue. And these are sort of the operations that sort of distinguish a queue from other abstract data types. Now, priority queue isn't that different from a queue, but it has a special feature. So before we talk about it, we'll just look at the priority queue counterparts for in queue, dequeue, and peek, right? So in queue is called insert in the priority queue because you're now not only in queuing it, you're inserting an element, and now every element retains some kind of priority with respect to other elements within the same priority queue. So now it's not really in queuing it because it's not going to be necessarily first in, first out. It'll be just insert and then max out. right? So it has a method called extract max, and if you do extract max, you can think of it like dequeuing. It's pretty much the same as dequeuing something, but now it has some kind of priority. So the maximum priority item, it'll extract that. And if you don't want to extract that and you just want to sort of peek at it, then it has its own method called max. So it'll just return the max element instead of extracting it and then returning. It'll just return it and it won't extract it out of the priority queue. Now, in addition to this, say with the example with music streaming we talked about, we want to play a song next. That is increasing the priority of some song, right? So we need to have some kind of way of doing that. So we have a method called increase priority of some kind of song. Let's say this song is X and we want to play it next. Oops, what just happened? Yeah, so we want to play the song next. So this K will specify the position we want to put the song at. We want to play it next. So maybe this K will look like 1 or 2 or something depending on what it represents. But yeah, you just specify the priority you want to set it at, and based on that, it'll play next or play after 2 songs or play after 5 songs or whatever you want. So yeah, so these are the queue and priority queue abstract data types. Again, this isn't talking about the um, you know uh, average case performance or worst case or best case performance at all, or it's not even talking about any sort of asymptotic bounds here. We're just looking at the behavior of these two. And after all, that's what we said abstract data types are. We're looking at the behavior of these data types, right? If we want to talk about the implementation of that, uh, how to implement, a priority queue or a queue, um, stay tuned. We can talk about that. And there's actually a very clever data structure called the heap, and we can use that to implement a priority queue very, very efficiently. So that's what we'll talk about next.